Question 11 says a farmer wants to put a fence around a vegetable garden. Only 3 sides must be fenced since a rock wall will form the 4th side. If he uses 40 meters of fencing, what is the maximum area for his vegetable garden possible? So I'm going to draw a little picture of the situation we have here. So we have vegetable garden here. One side is going to be by a rock wall. These other 3 sides are fence. So I'm going to call this side here L and this side W. And some things we know from our question and from what we know about rectangles is that the area of this rectangular plot is going to be equal to the length times the width. And from our question, we've been told that the amount of fence around the perimeter is going to be equal to 2 times the length for each of these sides plus the width here for this 3rd side. And from the question, we've been told that the total amount of fence used was 40 meters. So I'm going to take this second equation here and rearrange it to get one of the variables in terms of the other. And we can see that it's pretty simple to get W on its own. So I'm going to subtract 2L on both sides and get W is equal to 40 minus 2L. And so what I'm going to do now is go back to this area equation. So area equals the length times the width, because the area is what we want to find the maximum of. So this is the equation we actually want to get to look like a function. So I want to get rid of one of the variables here, and I'm going to plug in this expression for W in for W here. So this gives me area is equal to L times 40 minus 2L. And I'm going to multiply this L in to the brackets. So this gives me 40L minus 2L squared. And I'm just going to rearrange this a little bit, these two terms. So I'm going to put the negative 2L squared in the front. I'm adding 40L. And I just did this to make it a little bit more obvious that what we have here is a function that's in the form y equals ax squared plus bx plus c. But in this case, we don't have a term c. C is just equal to 0 in this case. And what we want to do is find what maximum area we get for a value of L, and what the value of L is at this maximum area. And essentially what we want to do for this function is figure out where its vertex is, because that's going to be the maximum of this function. And it's a little bit hard to see the vertex when the function's in this form. So what we want to do is change it to the form y equals a x minus p squared plus q, because that's going to be a little quite a bit more easier to see where the vertex is. So from your notes, there's those equations for how to translate each of these variables between the two functions. And so we know that between the two functions, a is just the same. And so a, we can see, is -2 here. It's the coefficient on the L squared term. So a is equal to -2. We want to find p. From your notes, we know that p is equal to -b over 2a. B in this case is 40. It's the coefficient on the L term. So we have a -40 over 2 times a, which is -2. This gives us -40 over -4, and that evaluates out to +10. Moving on to Q, in our notes, we know that Q is equal to 4AC minus B squared over 4A. Plugging those values in, A is -2, C we said is 0, there's no term without a variable L here. And B is 40, so we have a 40 squared here over 4 times -2. So this term here just evaluates out to 0, and we have 40 squared, which is 1,600. That's going to be a negative. And on the bottom, we have a -8. So -1,600 divided by -8 ends up being 200. So rewriting our equation here, we can see that essentially what we have is y equals, sorry, this is actually an A. A is essentially our y in this equation, and what we have here is a -2 times L minus 10. 10 is our value for P squared, plus 200, which is our value for Q. So we've changed this equation into this form, and now we can see that looking at this and using our values for P and Q, that we have a vertex, that the vertex of this function is at x equals 10, y equals 200. So since our y value corresponds to the area, we can see that the maximum area equals 200. And in the units we've been given, this is going to be 200 meters squared. And so this answers the question for question 11. Our maximum area is 200 meters squared. And we know that if we were asked to find the dimensions of this vegetable garden, we would know that L is equal to 10 meters, because that's the x, or the value for L when the area is 200 meters squared, and we could use that to find W based on the equations we've written. But this is all we need to do to answer this question, so 200 meters squared is the answer to question 11.